starting, driving, and power flow. Now that we understand the main parts of an electric car, it's time to see how everything works together in real life. In Part 1, we talked about the battery, motor, inverter, and controller, but knowing the parts is only half the story. What really matters is what happens when you actually use the car. In this video, we'll explain what happens when you start an electric car, how power flows when you press the accelerator, and why electric cars feel so smooth, quiet, and fast. Everything will be explained step by step in a simple way so anyone can understand it. Starting an electric car. When you press the start button in an electric car, you don't hear an engine roar like in a fuel car. This makes many first-time drivers think the car is off. But in reality, the car is fully awake and ready. Instead of starting an engine, the electric car performs a series of electronic checks. These checks happen in just a few seconds. The system checks the battery status to make sure there is enough charge and that everything is working safely. It checks the electric motor to confirm it is ready to spin. It also checks safety systems like brakes, sensors, and high-voltage connections. Once all these checks are complete, the car enters an active state. A small light or message on the dashboard usually confirms it. At this point, the car is ready to move instantly. Pressing the accelerator. In a fuel car, pressing the accelerator sends fuel and air into the engine, which then burns the fuel to create power. This process takes time and involves many moving parts. In an electric car, things are much simpler. When you press the accelerator pedal, it does not send fuel anywhere. Instead, it sends an electronic signal. This signal goes to the controller, which acts like the brain of the system. The controller decides exactly how much power is needed and sends instructions to the inverter. The inverter then converts the battery's DC electricity into AC electricity and sends it to the motor. The harder you press the pedal, the more electricity is sent to the motor. More electricity creates a stronger magnetic field inside the motor, which makes it spin faster. This entire process happens instantly, without delay. Instant torque. One of the biggest advantages of electric cars is instant torque. Torque is the pulling force that makes a car move forward. Electric motors can produce maximum torque from the very moment they start spinning. There is no waiting for fuel to burn and no need to build up engine speed. This is why electric cars feel so quick when starting from a stop. Even small electric cars can feel surprisingly powerful in city driving. The response is immediate, smooth, and predictable. Smooth acceleration. Another reason electric cars feel different is the transmission. Most electric cars use a single-speed transmission. This means there are no gears to shift while driving. In fuel cars, gear changes cause small pauses and vibrations. In electric cars, power flows continuously from the motor to the wheels. As a result, acceleration feels smooth and steady without jerks or sudden changes. This makes electric cars very comfortable to drive, especially for beginners and new drivers. The quiet operation also adds to the smooth feeling, since there is no engine noise or vibration. No idling. In fuel cars, the engine keeps running even when the car is stopped at a traffic light. This wastes fuel and produces emissions. Electric cars work differently. When you stop, the electric motor uses almost no power. There is no idling. The system simply waits. The moment you press the accelerator again, electricity flows instantly and the car moves. This is one of the reasons electric cars are very efficient in city traffic, where stopping and starting happens often. Energy usage and efficiency. Electric cars are much more efficient than fuel cars. Most of the energy stored in the battery is converted directly into motion. Very little energy is wasted as heat or noise. This is why electric cars are especially efficient in stop-and-go city driving, where fuel cars perform poorly. In this part, we learned how electric cars start, how power flows when you press the pedal, and why electric driving feels smooth, quiet, and fast. Subscribe to the channel so you don't miss Part 3, where we'll explain charging, regenerative braking, and battery management in a simple and practical way.